So length of a curve. Now, when we are in grade 8, 9, 10, we know how to find the length of a linear line. Length of a linear line. So we call it d here. So that d, I would say d squared here. It's easy for me to do that. Right? x2 minus x1 squared plus y2 minus y1 squared. So we can find the square root of that. So this is a very easy and common equation we use in our primary level classes. Now this is a straight line. This is a straight line. Now, if you think about this, most of the people memorize this and memorize this. But if you go into the proof of this one, you remember we have used the Pythagoras theorem. We got this right angle triangle. This is going to be, so this is going to be y2 minus y1. This is x2 minus x1. And this is your Pythagoras theorem used to that system. You can see. So it's essentially what we have done. We have applied the Pythagoras theorem for this straight line. Now, suppose you have a curve. You have a curve like this. Now you need to find the distance from A point to B point. So the distance means you have to find the distance along this curve like this. Distance. Now, what is the strategy to do that? Suppose you have this curve in Cartesian plane where, so let me draw the Cartesian plane here. So this is x here. So suppose the xi is your initial point and xf means x final is your final point, the upper boundary, upper x boundary. Now you need to find that length. So now that is not going to be easy. Why? Because this is a curve. This is not a straight line. So we have to find a method to do this. So think about this. I'm going to take 2 points here. I would say A prime and another point here, B prime. Right? So those 2 points are residing very close to each other. Now what I will do, I will, zoom that part here. It's like this. A prime here, B prime here. That AB distance is very small, so that if you draw a line, a straight line, the red straight line and the black curve is matching each other, almost matching each other. Then you can easily, why we do that business? Because if you think in that way, you can easily find you can easily use the Pythagoras theorem. Now suppose this distance is delta s, right? So this is delta y, this is delta x, right? So in delta, there are two meanings. Small is one of the meaning. Then the other one is difference. So delta x means if you want, you can think difference of x, or you can think small x. Delta x is a small x value. So here we get small x value concept. So delta x is a small x. Then you can say that delta S, small s distance, is comparable with, right, delta x squared plus delta y squared, and I put square here as well. So what I'm using here is the Pythagoras theorem. I'm using Pythagoras theorem to that small right angle triangle. Now, if you look into this Cartesian plot, your independent variable is x. So that means something is changing respect to x. So if you think about y also a function of x. Because of that reason, I'm going to divide the whole thing by delta x squared. Delta x squared, like this. So if you do so, you get delta s squared divided by delta x squared. Then you get 1 plus delta y squared divided by delta x squared. And this is a mathematical simplification we do. This is a mathematical simplification we do. Now what I will do, I will subject delta s here. When I subject delta s here, actually delta s divided by delta x, then when I do that, I have to take the square root of 1 plus delta y divided by delta x squared. Right? This is happening. Now, what we can do, we can rewrite this by cross multiplying delta x. So that would be delta s, small s value. This is not equal yet. This is comparable to 1 plus delta y divided by delta x. The whole thing squared square root times delta x. So essentially you are cross multiplying this here. So now what you have obtained here is the delta s value. That means the value from here to here. This value delta s, which is the value from a prime to b prime, you have calculated. Now you can see a prime b prime is this length. A prime b prime is this length. So likewise, you can have a prime b prime lengths everywhere like this until you are going to the other point. So again, so these delta s values are adding each other from this point to B point. So how many delta S points are there? So many, right? Are they continuous? Yes. Why they are continuous? Because they are connecting wall to wall. See, the next one is connected with this wall to wall. The next one, next gap is this wall to wall. See, wall to wall. This one is connected to this wall to wall. So that means these two are matching each other to make this. See, on top of each other. Okay, so wall to wall connection. Now, if you convert this logic into math, once you find this delta S, the second one also delta S, next one also delta S. So you are making delta S from this point to point B. That means if you look into this diagram, you are adding it from point A to B, that's true. But in X perspective, you are adding it from here to here. That means you are adding it from X initial to X final in X axis. In other words, we have to understand this very carefully. Now, why I am saying you are adding delta S values, yes, correct. But why I am saying you are adding from xi to xf from x-axis is because of this reason. You can see in the right hand side you have delta x here, so that is x dependent, right? X dependent. Now here you have delta y divided by delta x. You have delta y divided by delta x. So delta y divided by delta x, if you have something like this, then y should be a function of x. y should be a function of x. Why I'm saying you that? Because delta y divided by delta x is d dx of y, isn't it? I'll come back to that. ddx of y. This is nothing but that. So if you want to write ddx of y, this y should be a function of x, right? So what I want to say, that this delta x is a function of x and this guy also a function of x. Look how I'm writing that. So you have to go inside and see. That means this delta s, the way I have written it, this delta s should be a function of x. Okay, so that is the logic. Now, I have my delta s, which is 1 plus delta y divided by delta x squared square root times delta x here. Now what I will do, I will convert this into this form. I would say this is ds. I will make the equal sign. I can do the equal sign if you do the limit where delta x goes to 0. You remember, this is the first principle in differentiation. So, and then this becomes dy over dx under that condition. So this is delta x divided by delta, it's the other way around. Delta y divided by delta x times delta x here. Now, when I put this one, that becomes an equal sign. So when this is imposed, these things are converted to d. So ds is equal to 1 plus dy dx squared square root times dx. So that means when limit is applied to here, this delta becomes a d. So then when you write d, the limit is disappearing. So you should be able to write this way or that way. Doesn't matter. Once you have the understanding of what is the first principle of differentiation. Now, if you look into this one, this is very clear. Why? Because this is x already. And to write d dx, so this x should be a function of x. And then you can say that s should be a function of x as well. Should be very clear. So when I'm explaining this, I'm not dropping any logic, any single logic I'm not dropping. So now this is ds. So ds is a function of x now. That means s is changing with x. Now, if you go to the figure before, so you have this ds, but ds is there. ds is a function of s. ds is a function of x, and then x limit would be xi to xf. So if you want to find the total distance is nothing but integration from xi to x final ds. So I'm introducing what I'm doing is I'm introducing integral for both sides, xi to xf, like that, right? So I'm introducing the integral. So if I do so, I would get xi to xf 1 plus ddx of y square root dx. And if you look into this one is s here, right? S here, and then boundary would be xi to xf is equal to that. So s here, why? Because you have one, right? So it's just s. Your upper boundary and the lower boundary would be xf and xi. So that would be this.